This is my 14th video in my Casting Shadows series, where I continue to talk about shadows on stairs. I want to remind you of my book, Ellen's Guide to Casting Shadows, on Amazon, where the Kindle is only $5. To summarize the last video, let's look at vertical and horizontal poles and the shadows they cast onto this block. The vertical poles cast shadows on the ground and on the block that go toward the shadow vanishing point because these two surfaces are horizontal. The shadow on the riser is vertical. For horizontal poles, we get horizontal converging lines on both the ground and the block that converge toward the same vanishing point as the pole. For this red horizontal pole, we get horizontal converging lines on the horizontal surfaces and a diagonal shadow on the riser. Let's compare shadows cast by a horizontal handrail versus an inclined handrail. In both cases, shadows on risers go toward the handrail, here and here. They go toward the handrail. The difference is with shadows on the treads. For a horizontal handrail, the shadows on the treads converge toward the same vanishing point as the pole. For an inclined handrail, the shadows on the treads go away from the handrail. So in the first case, the shadows converge with the handrail. In the second case, shadows on treads angle away from the handrail. Here again, I'm comparing a horizontal handrail to an inclined handrail. So draw the light rays so we know that this part is cast by the horizontal handrail, while this part is cast by the inclined handrail. The shadows on the treads down here converge with the horizontal pole to a vanishing point on eye level. The shadows on the treads for the inclined handrail, however, go away from that handrail. Now, shadows on the risers for either one go toward the handrail. The difference is the degree of verticality. So this one for the horizontal handrail is not as vertical as the one for the inclined handrail. And if you can imagine having a vertical handrail, well, the shadows on the risers would then be vertical. So when we go from a horizontal to an incline to a vertical handrail, the shadows on the risers get increasingly vertical. Light rays from each end of this horizontal pole indicate that most of these shadows on the stairs are cast by that pole. So why are the shadows on the risers nearly vertical? They're supposed to be diagonal. Well, that's because the sun is nearly overhead. So there are two factors that cause shadows on risers to approach the vertical. The first one we talked about in the last slide, going from a horizontal to an incline to a vertical handrail. The other is illustrated here, which is as the sun approaches the zenith, or nearly overhead, the shadows on the risers become more vertical. When we're going upstairs, shadows on treads angle away from the handrail, while shadows on risers go toward the handrail. When we go downstairs, it seems to be the opposite. Shadows on treads go toward the handrail, and shadows on risers go away from the handrail. And that's because of our point of view. If we were down here looking up at these stairs, this line, while on top looks like it's going toward the handrail, from the bottom, we would determine that it is going away from the handrail. Shadows going downstairs are more difficult because we have to find the hidden lines of the stairs. This vertical pole casts this shadow, and it is composed of horizontal lines going toward the shadow direction and vertical lines on the vertical surfaces. This shadow is cast by this inclined handrail. So we get diagonal shadows on both the tread and the riser. For these complicated shadows, first find the light direction. One light ray would go from here to here, and another one would go from here to here. We can also use these horizontal platforms to find eye level. So if we followed these lines to where they converge, we would find a point on eye level that is the same level as the horizon. This vertical pole, as usual, casts horizontal converging lines on the treads that go toward the shadow vanishing point and vertical lines on the risers. For this vertical pole, we can see it right here on this picture. So light rays go from the top of it to the pseudo-sun, and shadow lines go from the bottom of it to the shadow vanishing point, which is on eye level, which is the same as the horizon. So eye level is for all vanishing points on horizontal surfaces, like the vanishing point on treads and for the shadow vanishing point. This level is for inclined vanishing points. And this line up here is for vanishing points on vertical surfaces like risers. Let's break down these shadows. So we have a vertical pole here that casts horizontal converging lines on the treads and vertical lines on the risers. The top of the window casts a shadow down here, and the bottom of the window casts a zigzag pattern on the staircase going toward it, away from it, toward it, away from it. And then the inclined handrail casts this shadow that would continue if it weren't interrupted by the staircase. And then we have shadows for each step. So this step, for example, casts this shadow. And we know what poles cast which shadows because they are connected by light rays. So number 2 here, for example, the light rays from number 2 connect to its shadow on the ground. Let's use these stairs to summarize my points because it's composed of a vertical handrail, an inclined handrail, and a horizontal handrail. For the vertical handrail, I chose a horizontal shadow direction for horizontal surfaces, and the shadow on the riser is always vertical because it's a vertical surface. For the inclined handrail, shadows on the treads go away from the incline, while shadows on the risers go toward the incline. And for the horizontal handrail, shadows on horizontal surfaces are horizontal or converging, and if we had a vertical surface, the shadow would be diagonal. Since this video is mainly about inclined handrail, let's break it down a little more and look at shadows on treads that move away from the incline. That differs from shadows for horizontal handrails, which converge or are parallel to that pole. For shadows on risers for this inclined handrail, they become more vertical as the incline becomes more vertical and as the sun direction becomes more vertical. In my next video, we'll look at shadows under overhangs.